Welcome to qnawire.
We have been given some sample data. The command has been executed 25 times, so there's our sample size. We know the sample mean, x bar, is 79.25, and we know the standard deviation of response times is 4. So that's from previous experience, that's the population standard deviation, sigma. That's 4. Now we want to make a two-sided confidence interval for the population mean, so the response time in general. Now the formula for this is x bar, point estimate, plus minus the margin of error, z sigma over root n. Z is my critical value here, and I'm using that because sigma is known. Sometimes you are not given the population standard deviation, and you're given the sample standard deviation. If that happens, you have to use t instead. But here we know sigma, so we get to use z, which is preferable. Let's make our interval. We have most of the information, we just need z. We get that from a level of confidence. So we need to assume normality here, which we've been told is fine. And that's the case. If I take every sample of size 25, take the sample means and plot them all out, I would see something also approximately normal. So this is using the central limit theorem. As sample size increases, sample means become more and more normally distributed. If n is at least 30, you don't need that normal approximation, because by that point the sample size is large enough that the sampling distribution is approximately normal, regardless of the shape of the population. Since we have a small sample, we need the original distribution to be reasonably normal, which we have. Now our sample needs, our confidence interval has to be wide enough to contain the middle 95% of this curve for 95% confidence. That leaves 5% in the tails, so the tail is 2.5%. Z is the z-score to exclude those tails. Now you might have a table of these. If not, use the inverse normal function on your calculator to get the critical value 1.960. Now we get to use this formula. X bar plus minus, I'm going to get the error, 1.96 multiplied by 4 over root 25 is 1.568. If I subtract that away from point estimate, I get the lower bounds of my interval, 77.682. If I add it onto my point estimate, I get the upper bounds of the interval, 80.818. There is my confidence interval for the population mean. I can say that I am 95% confident that the population mean is in this interval. Now, on to part B. What are the conclusions we can draw? So the first conclusion is interpreting the interval, saying that we are 95% confident that the average is in that interval. Now, if I look back at the question, the system manager wants to know if the mean response time exceeds 75. 75 isn't in my interval. That's a problem. 75 milliseconds is not in our interval. Now, you can think of this interval as a kind of range of plausible values for the population mean. I'm 95% confident the population mean is in there. So if you told me the mean is, say, 78, I would look at my interval and say, yeah, that's in the plausible range. I believe you. I wouldn't doubt that. But if you told me the population mean is 75, I would look at my interval and say, I don't believe you. 75 is not plausible. My entire interval is above that. So the conclusion that we're drawing here is that it looks like the population mean, whatever it is higher than 75. So the system manager will want to know that. So we have evidence that the population mean exceeds 75. We should alert the systems manager. They would be very interested in our results.